So what we're going to look at today is 1.5 angle pair relationships, and this is day 3. And I'm just going to do a little bit of talking before I get started, because if you've been watching the videos, you realize they keep getting cut off, and I'm not really sure why. Of course, I've restarted my computer. That's the ever famous trick, either turn it off and restart it or just let it reset. I've tried those things. So hopefully you can hear this entire diatribe while it's actually recording. But since I don't know, I don't want to keep cutting off the lessons. So I'm just kind of rambling on at the moment. It seems to be recording. I have flashing lights this time for the first time in a while. So just wanted to remind you that 1.4 was on Monday, the second half of 1.4. On Tuesday you had 1.5 day 1, on Wednesday you had 1.5 day 2, and today is Thursday and you have 1.5 day 3. Now, tomorrow is our Zoom day. It will be a lovely review day. On Monday is Labor Day, so you have the day off. Tuesday of next week is a review of sections 1.4 and 1.5, and on Wednesday you will be taking your second chapter test. It concentrates on sections 1.4 and 1.5, but we have all of the first part of the chapter 1 through 1.3. Any of that is fair game as well. So please understand that if there is something in the first half of the chapter you don't understand, you should go back and rewatch those videos. Though you can either go to the YouTube channel LHHS Geometry, or just go back to the previous week's assignments and check out the links for those YouTube videos. I know several of you had talked about partition issues. I am pretty sure there is a partition question on the test Wednesday, so you need to go back and review that. Okay, I think I've been talking long enough now that it should have given me an opportunity to teach. So 1.5 angle pair relationships, day 3, so that's what we've been talking about for the last few days. Today is September 3rd, and we're back to the same objective as Tuesday, to use the special angle pair relationships to find angle measures. So again, we're going to be calculating angle measures, so algebra is going to occur again. Okay, so we have a new term today, and it's called theorem. Okay, so we've already talked about what a postulate is when we did the segment addition postulate and when we did the angle addition postulate. So a postulate is a rule that is accepted without proof. So it's just accepted no matter how you do it. It's accepted. All the mathematicians got together and they said, hey, it works this way, and the other mathematicians said, oh yes it does, and they just accepted it. Whereas a theorem had to be proved, had to be proven. So if you think about the Pythagorean theorem, Pythagoras went to his math colleagues and he said, I think for every right triangle, if you square each leg and you add them, that's the same as the square of the hypotenuse. And several of his math friends said, no, we don't really see it. I mean, it kind of sounds reasonable, but we don't see it. You need to prove that that's the case for all right triangles. So postulates and theorems are both rules that we use. And the only difference between a postulate and a theorem is history. Did the mathematicians accept it, or did you have to prove it? And so that's how you come up with the two, why one's called a postulate, one's called a theorem. So the reason it's called postulate and theorem is because our first one is actually the postulate, if you're curious. And the second one is the theorem, if you're curious. And it's okay if you don't know the difference between the two. It's not really that important. What's important is you know what they say. Okay, both of them are what we call conditional statements. As long as the first half of the sentence is satisfied, then the second half will occur, and that's a conditional statement. For example, if it is raining, then I will take my umbrella. So once it rains, we know we're going to take our umbrella. If it's not raining, then we may or may not take our umbrella, and so a conditional statement tells you what would happen next if the first half was satisfied. Okay, so here goes. So if two angles form a linear pair, so if you get a diagram where you have a linear pair, then you will also know that they are supplementary. And a few of you are probably thinking, yeah, she talked about that the other day, so why make such a big deal out of it? Why is it a postulate? And the reason we make it a postulate is because not only are they rules, are postulates and theorems rules, they're actually shortcuts. So to get from them being a linear pair to the word that they are supplementary is actually a shortcut. And you would have to go through a couple of jumps to get from the front to the back. Okay, so what this would look like in picture is if you got a picture where you knew that the two angles form a linear pair, then you could say that those two angles are supplementary. So generally what comes about is somebody's like, well, why isn't this second line the postulate? Because a postulate and a theorem, remember, are rules, and rules are in general. They don't say Fred can drive when he's 16. They say anyone can drive when they're 16. So the rules are going to talk about generics, and so this would actually be the example to the postulate because it's one instance where this postulate works. Okay. The second one is about the vertical angles. If two angles are vertical angles, then they are congruent. And just as a reminder, the congruent symbol is the equal sign with the tilde. So here's an example of our theorem. It's a specific example to a general rule. If you have a diagram of vertical angles, then you can say very specifically that those two angles are congruent. So then angle 1 and angle 2 are congruent. So there's two things we need to know today. If two angles form a linear pair, then they are supplementary. And two, if two angles are vertical angles, then they are congruent. So if you remember from the notes the other day, I said basically things are either equal or you add them together. So basically, most things are going to be equal, not necessarily because they're vertical angles, but because a lot of things are congruent. So in today's lesson, we're either going to set them equal or add them together. Now, how do I know that? Because I know the definition of congruent means set equal, and I know the definition of supplementary means add together. So I have an example 0. That means you are not writing this down. You will not find it on your fill in the blank notes, and you do not have to put it on your personal notes. So the very first thing we need to do is Mrs. Rose Johnson needs to fix the question. Sorry about that. Okay, it says solve for x. Okay. So the first thing I want to do is I want to go back to yesterday and go, are these vertical angles or are they a linear pair? And so remember, the first question you ask yourself is, are they adjacent? Do they share a side? These do not share a side. So the next question is, are they formed by intersecting lines? The answer is yes. So these are vertical angles, and that would make these angles congruent because that's what the theorem says. Since the angles are vertical angles, we know the angles are congruent. But this is about measures. So since we know the angles are congruent, the definition says their measures are equal. So these are things we need to think about. We don't necessarily have to write them down, but they're things we have to think about. So these two angles are congruent, so their two measures are equal. And this is actually going to be our geometry. I know it looks like algebra, but it is our geometry because you can't show me what your brain is thinking on these two lines. This is your geometry that you're showing me. So now we're going to do the algebra. I'm going to add 9. So 45 equals 5x. We're going to divide by 5. So x is 9, and it said solve for x, so we're good to go. So let me review this one more time. If you've got linear pair, we're going to say they're supplementary. If they're vertical angles, they're congruent. If they're linear pair and they're supplementary, they're going to add together. If they're vertical angles, they're congruent, which means they're equal. Okay, so let's look at example 1, which you should be doing on your paper. It says solve for x. So is this vertical angles or a linear pair? Are they adjacent? Yes, they are. They share this side right here. Are the sides that are not shared making a line? Yes, they are. So we don't really care about this part of the diagram. So they are a linear pair. And so since they're a linear pair, the angles are supplementary. I'm just writing down what I'm saying and thinking, so in case you want to write it down. And so since we know they're supplementary, we know from a past lesson that their measure has a sum equal to 180 degrees. Okay. So now that I've decided they're a linear pair, I now know that if I add the two together, they will equal 180 degrees. Combine like terms because they're on the same side of the equal sign. So 16x equals 20. Sorry, let me say that again. 16x plus 20 equals 180 because I'm just bringing everything else down. Subtract 20. So 16x equals 160. Divide by 16 and x is 10. Now it said solve for x, so we are done in that category. So what I want you to do is I want you to pause the video and I want you to try number 2 on your own and make sure that you think through the process. Don't just jump somewhere. Actively think through the process. Welcome back. So were the two angles adjacent? No, they are not. Are they formed by two intersecting lines? Yes, they are. So these are vertical angles. And if they're vertical angles, then we know that the angles are congruent. And since the angles are congruent, we know their measures are equal. So, since we know they're vertical angles, we know we can set their measures equal. So 6y equals 2y plus 24. Subtract 2y from both sides, and I get 4y equals 24. Divide by 4, and y equals 6. Always double check your question. It says solve for y, therefore we're done. Okay. So our last question for the day is a writing question. Let's think about what we've done and what we've learned. And so here's a word problem. And then I have a question about the word problem. Not that you're going to solve it, you're going to answer some questions about it. Okay. Number 3 says, two angles form a linear pair. The measure of one angle is 4 times the measure of the other angle. Find the measure of each angle. So here's the question. Are the two angles in question, are the two angles congruent, complementary, or supplementary? and how do you know? Please use key vocabulary to answer the question. So meaning use vocabulary words that you've learned in our geometry class to answer this question. Please pause the video while you answer that. Okay, so I know that was a quick change artist there. Let's look at what we have here. Okay, so the two angles form a linear pair. So if they're forming a linear pair, then there's a postulate that says the linear pair are supplementary. So we now know the two angles are supplementary. How do you know? Please do not say, because the notes say so. Please do not say, because that's what Mrs. Rose Johnson told us. So just like yesterday's writing example, you want to go back to the definition, but in this case we don't have a definition, we have a postulate. You want to go back to the postulate and pull from it to answer our question. So here we go. The two angles are supplementary, so we decided it was a linear pair, because, and then I just wrote the postulate. If two angles form a linear pair, then they are supplementary. I forgot my comma. Then they are supplementary. Or you can shorten this sentence and say, these two angles are supplementary because linear pair are supplementary. It's the same postulate, it's just not put in if-then form. Okay. Somebody might have said these two angles are supplementary because they're a linear pair, and you're on the right track. But anytime we say because in geometry and you have a definition or a postulate or a theorem to back you up, then you should state those. Okay. So don't forget that Wednesday and Thursday's assignment is due by 11:59 tomorrow night, Friday night. Please make sure that you've answered the question of the week and posted a reply to somebody's post, and we will see you on Tuesday. Have a spectacular 3-day weekend. Actually, that's not true. I will see you tomorrow in Zoom, and then have a 3-day weekend. And as always, please make sure you email your teachers if you have questions.